Hello, folks. I'm Naveen. I'm an engineering manager at Meta. I support the Presto, Prestissimo, Preston, Spark, and Velox teams. So pretty much all the terms that we covered. Like I had the opportunity to kind of support these teams for the last 4 years, and the journey that I just look back, right? Like how did the name Velox came in and the Prestissimo came in? I think it was the word Prestissimo is the kind of the interesting time, right? Like I don't know if Pedro is here. So Pedro was like, Naveen, we need to have a name for Presto and Velox. I was like, what's wrong with Presto and Velox, right? No, we need a term to kind of people so that they can identify with that, right? And then he was like, okay, then let's name it Prestissimo. Like, what the hell is Prestissimo? Like, you know, so in the music world, it seems Presto means some beats per minute. Again, I'm not a music person. And Prestissimo is faster than Presto with more beats per minute, something. And it took us a while. I think I see a bunch of engineers who were working initially with us on that one. So it took us a while to kind of understand that name and to get used to that name. And I'm super happy to see that today many talks are related to that. So the bunch of learnings that we had over the last 4 years, I've shared some of them as we go through. So I think the agenda would be like, first we'll introduce like kind of Presto for anyone who doesn't know it fully yet. And then I'll introduce you the scale at Meta and how Presto evolved in Meta, right from the start, and what were the challenges, what led us to kind of invent Velox and then Prestissimo, and then why did we go towards the direction of Presto and Spark, etc. And what's the current status? I think Tim spoke about how the native worker is in production. I'll show some of the facts there. And then going forward, like what are we gonna do? Okay, I think introduction, I think most of you already aware, so just for kind of, just for the sanity there. Presto is open source distributed SQL query engine. We open sourced back in 2013, and we are extremely proud of our initial foundation members of like Uber, Alibaba, Intel, IBM, HANA. And as most of you guys are aware, Presto is a shared everything architecture where it's a kind of all queries share the resources, and there is no kind of isolation really, which has its own problems, but at the same time, it also gives you the power, like, you know, it's super straightforward to use. But at the same time, when it was initially started, it was optimized for latency over scalability, because that was the need at that time at Meta, at least. Now let me introduce a little bit of scale again. So it's kind of our warehouse is kind of tens of exabytes. The exact number is I cannot put it in. And every day we had to replicate similar size of the data, and then we have like thousands of pipelines and tens of thousands of users who use Presto every day, on kind of on a daily basis at Meta. So, and the scale at which that we operate, it just nothing works. And then every day we have a different set of problems, especially the multi-tenancy nature of Presto adds to the problems at our scale, right? And then there are multiple ways people use Presto at Meta. One of the ways are like more interactive, where people want to explore using a SQL query interface or dashboards or experimentation platforms. So these are the interactive kind of users. And then the second set of users are data engineers, data scientists creating the ETL pipelines on top of Presto, where generally the scale is like up to tens of minutes to hours. Generally, Presto doesn't have the fault tolerance model, so it limits it at maybe 1 or 2 hours. That too, sometimes we see the scenarios, right? So Presto is used widely across like pretty much all the use cases that we see. So that's the reason it's a wide variety of users. It's difficult for us to segment. There are 2 or 3 categories. There are like almost every kind of category of users use it. Now let's go on to the evolution at Meta. Like how was it in the past, and what were the problems that made us rethink Presto? Like I think I like the way Tim put it, Presto 2.0, in a way. Like, you know, where was the seeds that caused those things, right? And the first warehouse at Meta, this is between 2013 and 2019, a bit predates me. So there is a single zettabyte scale storage. So we invented our own HDFS equivalent, and all the file formats are unified. The metadata is unified for this warehouse data. And then we have a bunch of engines which were satisfying the compute needs of Meta over this storage. So back in the day, I don't remember the exact year, but Meta made the call that Hive will be deprecated. And that's when Presto kind of had to take a lot of that workload. And that's the reason, at least internally at Meta, Presto went towards the Hive workload to get it onboarded towards Presto. So that made our investment on the interactive side to make it faster and faster for our users a little bit delayed. And hence we saw emergence of other engines internally, which we called it Kubrick, Raptor, etc. What they were doing is copying the data essentially from the storage into either RAM and cubing it, or into SSDs, so the faster access. So naturally they were faster than Presto, and then but they had to maintain the ingestion pipelines and then associated other kind of issues we'll talk about, right? And then, of course, there is Spark always, like for the ETL jobs, which were like the jobs which couldn't move from Hive to Presto, so they had to move to Spark. And what are the challenges with this approach? If you see, there are multiple interfaces, the different query languages we have Kubrick SQL, Presto SQL, Hive QL, whatnot. And I think latency-wise, users have to pick, hey, if I need seconds latency, I need to go to Kubrick because it's in memory completely. If I need more of exploratory data up to minutes, I have to go to Presto. And if I need long-running queries, which I don't know if I need long-running queries, so Presto used to fail them, and then we used to ask them to go to Spark. And then storage, in some cases it's co-located. They need to invest in the ingestion pipelines. And in some cases, it's disaggregated, like in the case of Presto and Spark. And even isolation, like there is in-memory and share everything for a few engines, and then container isolation for the others. So in a way, users are really confused with this, number one, because they don't know. There's too much of fragmentation there. And the second major problem that we had was, as any large company would have, there are so many security restrictions, privacy restrictions, regulations we have to do. And each and every engine need to adhere to that. And especially when you're copying the data from warehouse, right? So the lineage needs to be tracked, and all these privacy security things get carried away there. So all these added to a lot of issues during that time. What we did as a first go between 2019 and 2021, I think we went through all the other variants that were doing interactive and said that, okay, why don't we build a kind of disaggregated storage for Presto where it would be backed by a local SSD, which does different kinds of caching there. And we invested in hierarchical caching. When I say hierarchical, like, metadata caching, list file caching of storage, fragment result caching of partial results, and data caching itself. We collaborated with Alexio on that one. And all these cachings led to the emergence of RaptorX, which just unified Kubrick, like the bunch of engines. We just kind of killed all of them and then made everything onto Presto RaptorX. So by the end of 2021, with different kind of adaptive filtering approaches that we did, Presto, or codename RaptorX, became the default interactive engine at Meta. So all the other engines which used to create the fragmentation were gone. And now this was the state almost at the end of 2021, where there were the two kind of divisions. One is Presto SQL for like seconds to minutes, tens of minutes, and then everything simplified by the RaptorX story. And then Hive QL, which is our own internal language, which is kind of a mix of Spark SQL and Hive SQL there, which was handling the long-running queries with shuffle-based approach and stuff. And then we did a survey across compute users and see, okay, what do they care about, right? Because there was always this thing, should Presto do this, should Spark do this kind of approaches? So we went to compute users and we asked, like, tens of thousands of different kinds of users, like, what do you care about, right? I think some of the common points that came are, with respect to authoring, people are like, hey, can I use the same SQL, ideally, to run it across, right? I think Tim's example of, I have 50 Chrome tabs, should I move to a new computer? So the problem is they don't even know if that SQL is going to complete in 1 hour or not, right? Presto comes back after an hour and says, hey, so you ran out of that 5 terabytes memory, hence we have to kill you. And then we ask them, hey, go write your query in Spark SQL or HiveQL and run it in Presto, Spark. And then those UDFs are not available there because Presto has its own set of UDFs. That brings to a second problem. Hey, how do I port these UDFs? How do I share these UDFs? And then the third one is, I think it's more recently also catching up, is how can we use Python APIs to query Presto? Because either they are used to Python APIs in the past, or with the evolving kind of ML kind of workloads, Python is becoming more popular on that. So the authoring, those were the questions that we were set to tackle. And then the performance and efficiency, which is a never-ending problem, especially at the large companies like Meta. How do I speed up my interactive queries, right? Ideally, I expect everything to be like, blazing fast. And how do we get more efficiency in terms of CPU? Because we spend tens of megawatts on Presto internally. So it's kind of, efficiency is always on top of the mind for our company. And then the last one is smarter warehouse. This is like, hey, why are you leaking all this information of whether it's Presto or Spark or God knows what? Why can't you guys be smarter and just, I will express in whatever SQL or Python, whatever, and you take it and run it wherever you want. We don't care about the runtime and stuff, we just care about the results, right? So that's what they're saying. So we set out with this journey of solving these problems. Some of them are kind of solved, some of them are in progress, some of them we haven't yet made a dent, so we'll go through those things. I think the first improvements that we did were performance and efficiency. I think this is where the birth of Velox and hence the integration with Velox called Prestissimo were born. And well, during this time we had enough debates on whether a full C++ worker is the right option, or should we go with the JNI approach? Should we do scan operators first on C++, a hybrid model? Or should we do a pure approach of everything C++ ground up, right? Well, I think there was enough debates. I must say that that's one of the biggest conflict scenario within the team at that time. Like team was vertically split on this versus that. So, I mean, it's fair, right? Without data, we can't say a complete rewrite will pay off, right? But we took the bold step of rewriting completely on top of Velox. And at least the numbers are showing that we made the right call there. We're seeing 2x efficiency in terms of CPU, cutting the number of machines that are needed directly by 2 times. And we also see a lot of performance improvements. I think we published the TPCH and TPDS benchmarks, and also give an example of internal workloads later. But that paid off. So the first step in solving the performance and efficiency problems was definitely Prestissimo via Velox. And then, so that solved, at least temporarily gave us a buffer. Again, as I told you, performance and efficiency is a never-ending problem. So at least it gave us a buffer where people were able to do more with the capacity that they had. Like experimentation users at Meta were getting blocked because there was no hardware available for them. And with this, they're able to do 3 to 4x more experiments. And that directly contributes to so many other things at Meta, right? But it's a never-ending thing. It's we made a dent there. Now the next one is authoring. This is about like I have a SQL, I ran it on interactive way or something. It ran for 10 minutes and it failed with whom. Or tomorrow my data increased and it might need to run for 1 hour or 2 hours. What do? I need to use the same UDFs. I don't want to rewrite it again, right? So this is where I think Presto on Spark. So this is, again, when it started, it was also a kind of controversial initiative in a way. So where turn each Presto worker into a library and leverage Spark core for what it does the best, which is scheduling, isolation, and failure recovery, right? So one of the lessons we learned here is don't reinvent the wheel. So leverage what Spark does best and then convert Presto worker into a library and see what comes out of it, right? And here, of course, we had to invest a lot in the optimizers because I think in a way we were trying to mimic Spark in a way. So we had to kind of enhance our optimizers to get certain things. I think Lublin and Feilong are going to talk about some of the history-based optimizers and other kind of optimizations we have to do for our production workloads. And then we started leveraging the shuffle. Basically, one of the disadvantages of Presto, not disadvantages, it was not built up for as, it's all in memory, and there's no materialization of the shuffle, right? So that differentiates Spark a lot. So I think we integrated with the shuffle layer internally we have. So that way, that's where the project Presto on Spark is born. So where it's pushing Presto SQL and getting rid of HQL on the right. So where everything is Presto on the top, people express it once, and where we run it, how we run it, whether we use materialized shuffle, whether we don't use it, whether we run it on Presto runtime, whether we run it on Spark runtime, it's completely, the control completely comes back to our teams in a way. Okay, with that, I think with Velox coming in, with people using the same SQL, again, these are in progress, these are not completely done, because moving all the workloads to the same thing, to the same Presto SQL will take more time. But at least having all the UDFs together in Velox, you'll get access to both Presto and Presto on Spark, etc. And the same SQL is used across. So these are the another two we addressed. And the other two problems, we haven't yet made a dent. The Python APIs and then the smarter warehouse, where we need more intelligence to understand the user queries and what they want. So the current status is there is still Presto ANSYS SQL and HiQL, and then 3 kinds of evals. One is the Java eval, C++ eval, and Spark's Java eval. And then we have 2 runtimes, right? But eventually, we're going towards the state where there is Presto, codename Prestissimo there, which will take care of all the in-memory in-memory compute. And then there is Presto on Spark, which leverages the same Presto plan to run it on Spark. So that way, contributing to the defragmentation that we generally see in this space. So again, this is in progress thing. It might, I'm sure it will take more years on this one, right? So, because the footprint of this box here is, I think 70 or 80 megawatts. I could say it's a ballpark at that point. So it's not a trivial thing to converge here. Yeah, so I think some of the numbers I want to share is Presto on Spark currently is 15% of our warehouse footprint. So it organically grew. We didn't take any active steps to migrate stuff, but it organically grew because that's the power where people wrote their Presto SQL and it didn't work out for them. So they started using Presto on Spark and it worked for them, right? And then Prestissimo, which is of course Presto on Velox, 1/3 of interactive workloads are running in production, and 60% reduction in hardware footprint, and 40% latency reductions is what we see. And I think Amit will cover Prestissimo in the talk Prestissimo. He'll talk through the journey of what went in productionizing this and what are the wins that we saw and how and why, right? And then the next part, it's not in production, so that's the reason I can't share the numbers. This is for the non-interactive workloads on Presto. Interactive is like milliseconds to seconds, right? But the people use internally Presto for like minutes kind of warehouse scheduled queries. And then this is another part I think we are currently working on. And we do see pretty solid numbers there as well. It's not ready for us to kind of publish yet, but I think that would be the next exciting milestone on this project. I think with that, plus whatever interactive, will put us above 50% at Meta on Velox. So that's where I think the next milestone is going to be very exciting. Okay. Conclusion. I think defragmentation, especially in larger companies that I've seen, there is so much of defragmentation. We invent new engines to solve a specific problem, and that turned out to be very expensive later, right? I think slowly what we realized is Presto is the centerpiece of Meta's warehouse. And then its language, I think it's his power, I would say, because Presto SQL is the language which people just love. And this also helped us, or will help us more, reduce user interfaces to provide simplicity and consistency, and then avoid double investments with respect to privacy, security, and many other features that are needed, right? And pretty much all the features that I spoke about, whether it's Prestissimo, whether it's Velox, whether it's Presto on Spark, all of them are open source. And more or less battle tested at meta scale. So yeah, please feel free to kind of join the community and then start contributing on this. I think I already introduced the 3 talks we have. I think Prestissimo is the journey of how we ended up productionizing it and what are the learnings from it. I think Amit is going to cover that. And optimizers as Metascale and history-based optimizer, which really helped us to get the Presto on Spark kind of workload. Feilong and Ublena are going to cover that. Again, I think get involved. Those are the Slack channels for both Presto and Velox. And so I think it's a pretty vibrant community, especially after Velox joining the forces here with Prestissimo. I think we do see a lot more attention that we are getting, and I'm happy to see that, and I hope it will continue in that way. Again, we are hiring. Yeah, please reach out to me.